There we go. Okay. For all of our friends in the United States, happy Thanksgiving. I have to take a moment and tell you what I'm thankful for, because I've not been so thankful in many, many, many years. First off, I'm thankful that I'm still alive and that everybody that I care deeply about is still alive. COVID didn't kill anybody that I cared about deeply. It did kill people I knew, and it killed people I cared about, but I got to keep the ones that were my favorites, so I'm very thankful for that. And I'm very sorry for anybody's loss who wasn't as fortunate as I was through that period. And I'm thankful for everybody who's watching this video right now or watches it later on replay or repeat or whatever you want to call it, video on demand. There's nothing better than getting on here every day and teaching people things that other people would keep out of their grasp behind paywalls and expensive books and expensive courses. And I'm glad that I can just, do it for free like a cheap whore. All right. I guess that wouldn't make me cheap. That would make me free. Vanilla JavaScript. Here's what I think most people do. I think most people take you through. The first thing they're going to do is show you variables. The last thing you want to show a new developer or a new programmer are variables, especially in JavaScript. Why especially in JavaScript? Well, JavaScript is JavaScript, man. It's freaking weird. So I'm just going to go in. I'm just going to create a folder. I don't really care. I'll put this into a GitHub repo later and put it onto the thing. If you want to get access to it, you'll get it in the description along with the tip jar that you'll see QR codes for. That's the only way that we actually can survive. Like literally your guys' tips are the thing that keeps the channel on the air. So I had to buy that. I had to buy that SSD drive to replace my SSD drive. And I want to thank Thomas Lawrenson and Chris Loggins and Joshua Vaughn. They have all tipped the channel graciously. And of course, I want to thank Julie and Ryan. Okay, so let me just make a folder. I'm just going to call this Vanilla JS Day 1. Whoops. If I can type. Vanilla JS Day 1. I'm going to use the $_ so I don't have to type all that again. And now I'm in an empty folder. I'm just going to open that up in Visual Studio Code. Hydrate. You don't have to wonder what the first file is. The first file is always index. You don't have to come up with a creative name. You don't have to figure out what it's supposed to be. It's index. Index.html, index.css, index.js. Or JSX if you're doing JavaScript, XML, and React. But we're not doing that today. We're just doing regular JavaScript. So here's what I would say. Listen, all languages have functions. But JavaScript is all about the function. The function is everything to JavaScript. Some people will be like, well, objects are everything to JavaScript. No, objects are just functions. Functions are everything in Java. Arrays are just objects. Objects are just functions. Well, I mean, it's the result of a function call. Functions are everything. What does a function look like? You can create a function like this. You can create a function like this. They are identical with a few small changes that will only matter if you're using ES6 classes, which I don't. This is an anonymous function. It does not bind. Well, if I get into that, you're not going to understand it yet. So just know there's more than one way of creating a function. Right now, I want you just to not care about which one you use. It doesn't matter yet. What matters is that it's a function. Okay, so what can functions do? Well, let's go super simple. Everybody's used a calculator. You can add A and you can add B, right? And you should be able to get back A plus B. This is a function. That's all it is. Functions are just mathematical expressions. It's just that in programming, we can taint these beautiful mathematical expressions and turn them into garbage. you can't do that in math because just the way the math works, you can't fill it up with junk that doesn't fit algebraic computation or computational algebra. Okay, so you've got an add, you've got the ability. What if you have what if you have a string that's like I've got some data here. It's like this is part 1. Here's part 2. Here's part 3. And I'm storing them all together. And I just want a simple way to, like, you know, break it up. Return 3 values instead of 1. Well, guess what? You could create a function for that. Your function could say something like split on dot. If you wanted to make it totally generic. But if you were like decode triplet, maybe. Now this is much closer to like the business language, or like what it really does. The other one's very generic. It's very much about like the details of what the function does, and not really about like why the function does the thing that it does. Whereas decode triplet, I would argue, is much more about telling you what you're actually doing. We're going to pass in a string here. Let's call it a triplet because that's what we're saying it is. And then we could just do triplet.split because it's a string, and we can just split it on the dot, and you're going to get back an array of those 3 things. So it decodes the triplet. So functions are just essentially, think of them like machines. They take some input like oil and gas, and they have some output like, you know, a running engine that can power a car. Both of these are what are called pure functions. They do not modify anything outside of themselves. They take values in, they return a value out. It takes a value in, it returns a value out. There's no assignment to variables. There's no modification of anything. It's just input output. These are called pure functions, and these are the best kind of functions. If you can write your software so that 90% or better are just pure functions, it will be incredibly easy to debug. Every time you create something that is not a pure function, we'll get into that a little bit later. There's no reason to show you immediately what the wrong thing is to do when I can instead show you what the right thing is to do. Pure functions are just gravy. If you have pure functions everywhere, everything becomes easy to debug, everything becomes composable. As soon as you start doing side effects and other stuff, it gets gross. So what is a side effect? To understand what a side effect is, we're going to have to introduce something called a variable, or really what it is an assignment. There's a couple of ways to assign a value or a variable in JavaScript. You've got let, you've got const, you've got var, but don't ever use it. Just don't use it. So there's no reason to use it. It's dead. It's dead to me. It doesn't exist. So let means that you're going to define something, and then you're going to do something with it later on. You're not going to change it here. So in JavaScript, you might have something like this. That's now no longer a pure function. We have modified something outside of itself. The variable is specified at the first level. The function stuff is at the second level. We have modified something from the first level inside the second level. That is a side effect. Now, you can't do a whole lot in JavaScript unless at some point you do some things like this. But remember, 90% or better pure functions, 10% non-pure. Okay, so we don't want to do that. What if we had a function that was supposed to take some array and it was going to add something to the array, right? Add item to array. You got this new thing called add item to array. Let's say that we have an array here. We have a variable, which is just a name, and it's pointing to a thing. And the thing in this case is an array. And what I want you to just store in the back of your mind is that arrays, objects, functions, and closures well, technically this is pointer to function, but ignore the pointer for a minute. Objects, arrays, functions, and closures. I'll explain closure in a minute. These are all stored on the heap. It's very important. JavaScript doesn't do JavaScript doesn't allow you to do memory management. So you have to understand what JavaScript is doing so that you can do good memory management just through good code. Well, you won't write any code that will prevent good memory management from happening if you understand how memory management works. There's no way to really optimize for memory management in JavaScript, but you could certainly de-optimize your memory in JavaScript by writing garbage code. Okay, so we got an array. It's empty. It doesn't have anything in it yet. And we know it's stored on the heap. What is the heap? The heap is unsized. It can grow to whatever size you need. You allocate it as you need it. You have all the memory that you had allocated used up. You just grab more. JavaScript will just keep grabbing more for you from the heap. You don't have to think about it. There's also the stack. The stack is sized. What I need you to remember about these two things is only this. The stack has a size and it can't be changed later. The heap is dynamic and it can be reallocated at any time. It can be released. It could be, you can create extra stuff. Arrays, objects, functions, closures are all on the heap. So in that case, what's on the stack then? Let's have a new thing. And let's just give it a 1. Okay, this is a value. This is not an object. It's not an array. It's not a function. It's not a closure. It's a value. And values are stored on the heap. So string, number, boolean, function calls are stored on the, that's technically not true. The function that will call will be stored on a stack, but it's a different stack. It's the event stack. So let's leave it out of there. So we got string, we got number, we got boolean. What else? We have undefined, which is the base value. There's also null. You really don't want to ever use null. Null's bad. Stay away from null. I'll show you how to deal and nullify null later, but just stay away from null. Null is a terrible idea. Having two base values, an undefined and a null, is a terrible idea in programming. It is not needed. Okay, so strings, numbers, booleans, undefineds, nulls, but we're not going to use them. What else is there? That's basically it. Those are all stored on the stack. Okay, so if we have a variable called array and a variable called new thing, and we want to take the new thing and put it onto some existing thing, what if we have like 038? We want to put a 1 onto 038. We have a function to do it. We don't want to do something like this. We could certainly push on a new thing, right? We could say the new value is here. Let's call that new val, just because it's a value. We could certainly do that, and then we could return the array. The problem with this is we are doing a side effect. This was defined outside of our function, therefore it's a side effect. It's no longer a pure thing. There's a bunch of different ways to do this, but I would just say that this is not how you want to create your functions, because you don't want to be doing these side effects. So how might you do it? Well, you would pass in the array. And this is why you need to know where things are stored, if they're stored on the heap or if they're stored on the stack, because this new value will copy. It's a string, a number, a boolean, it's undefined, or it's a null. It's some value thing. I guess date would be in here too. No, date would have to be over here, because date's an object. So string, number, boolean, undefined, we got our date, we got our objects, all that stuff up there. It's a new value, so this is going to be a copy. So like, we'll literally get a copy of this value that will only exist inside of this scope. That's how it works. But this is an array. Arrays are stored on the heap. Okay, so because arrays are dynamically sized, they're stored on the heap, they can grow, they can shrink. This is passed by reference. Which is also on the stack. Reference to functions. The function itself is on the heap, but the reference to the function is on the stack. Okay, so this one is being passed in, which means that if we modify it, it'll change. This one's being copied, which means if we modify it locally, it won't change this thing because it's a copy. How can we know that this is true? Well, how about we call add item to array. We pass in our array, and we pass in our new val. What if we were to change that new val inside of here? I already have a 3. Let's use a 4. Okay, so I'm going to call my function, which is going to modify the array, and it's also going to modify the new val, but it's going to modify the new val inside of this scope. Inside of, think of it like a box, where the variables live inside of the box, but they don't live outside of the box. So this is your scope, this is the box. This variable was changed inside of here, but it's copied in. It's not passed by reference. This is an array, it's a reference pass because it's a date, an array, an object, you know. So this one is going to be modified. We're going to get back our array. We're going to take a look at the new value too. So how do you run something like this? Well, you can just open it up in Node. So our new value is still 1, right? And we did put a 4 on there, which is strange. So what's going on here? This is why you don't want to write this kind of code. This is exactly why you don't want to write this kind of code. This is confusing as all get out. This is confusing as could be. I would use foul language, but I'm trying not to do that sort of thing. This is really, really confusing. New val was 1. We're trying to add 1 to our array, but it was mutated inside. It was passed in. Like, it's a 4 here, but it's a 1 here. Okay, well, the function was clearly called before he printed it out, so shouldn't this also be a 4? And the answer is no, because this is copied by value. This is by value. This is by reference. The references are not copied. The references are a pointer to a piece of memory somewhere. Copies are just a copy of the memory. So if you change the copy, it doesn't change the original thing. If you clone a sheep and you shoot the clone, the original sheep doesn't die. Okay, so we've uncovered one of the things that makes people pull their hair out with JavaScript already. The concept that if you set values and then you change values inside of functions, those values are not changed anywhere else. Let's get rid of that. That's just gross. We're passing in an array. We're passing in a new value. If we do that now, we run our code, we get back what we expect, which is 0381, and the new value is still a 1. Okay, so that cleans it up just a little bit. Now, is this a useful function? I mean, maybe. Maybe not. It depends on what you're building, what the language of the project is. Maybe you're building a really simplified API/interface for like beginning users. It might make sense. But we're really just harnessing something that's already existing on the array object. Okay, the whole point of this is just to show you how important functions are, how important pure functions are. How do you make something pure? How do you make something impure? And then what kind of stupid stuff can happen when you're impure? It gets those constraints to keep the things pure are there for a reason. They've been there since like the 70s or the 80s when people figured out side effects were a bad idea. They've been around for a long idea. One of the very first lessons I ever got in programming as a kid was side effects were bad. Like literally the first 3 days of programming, it was in there. It was don't do side effects. And we were writing in like BASIC or something. So this is not a new concept. All right. Side effects bad, pure function good. Okay, we've gotten that far. Let me actually put that in again. Let's say impure function. And let's just save that as impure and create a new one. Because all of the source code will be available afterwards and you'll be able to get your little fingers on it. All right. Pure functions good. Side effects bad. We sort of need to talk about a concept that would be considered advanced for most people. It's called closure, and it's a way. Basically, we're going to break the rule that I just talked about. So this is the other 10% of your code or less. 9% or less can be impure. And there needs to be a damn good reason why it's impure. And one of those reasons might be a closure. So what is a closure? Let's say that we have a variable called I and it equals 0. We have this closure thing. And what we want to do is we want to make it so that, remember in the other example where we modified the value to 4, but then it still returned 1. It's confusing. It's like, do you want 4 or do you want 1? Which one of these do you actually want? A closure will allow you to change. Let's say that we call this a stepper. It's going to start at 0. So if we do this, if we put this up here, we're going to have just code laying out on the global object, which don't worry about that as yet. We're going to cover that a little bit, but it's not good. You want the least amount of global object stuff as you can. So let's create this as a closure. Okay, so what happens if we scope this inside of here? Can we get it outside? Can we get an eye out here? Well, let's try it. Let's see, we got an error. And the error is that I is not defined, so no, we can't do that. Okay. And that's because it's defined inside of here. What happens if we do something like this? Whoops. Where's my node command? I is not defined. Okay, so we can't do that either. Where did my code go? Oh, this is the wrong one. There we go. Run it again just to make sure. Yes, okay. So whether we use let, whether we use var, whatever, it doesn't matter. It's not going to jump out of here. Some people have the idea that if you use var, like your I will end up here. It's not true. Also, don't ever use var. That was just a point I wanted to make, that like var is not going to make things magically jump out of here. Var, let, all of those get hoisted. They just get hoisted like this. If you create a const of foo down here, right? This will get hoisted at runtime up to here. I say just don't do it. Like there's no reason to define some shit way down here anyway. If you do that, your code's too long, your function's too long, you've got other problems anyway. Okay, so I starts off at 0. The key to, and this is why I say that JavaScript is all about the function. The key to returning a closure is that you have to return not a value, because remember, values are by value. They're copies. We need something that's a reference, something that's passed by reference, so that it won't get cleaned up when all the values get cleared out of the stack. Well, there's something for that. It's called a function. So we can return a function from a function. Now, this weirds some people out because they come from really stupid languages where you can't do this. Sorry, but this is actually not that hard to comprehend, and it's something that I'm sorry that your other languages didn't support. They should have. So a function can return a function. What does that look like? Well, this still is going to have some sort of return too, right? What if we returned I plus 1? All right, so how would we call this? Well, first off, we have to have a reference to the stepper. Let's just call it S for now. And this is our stepper. It doesn't take any arguments, right? It's just parentheses to call the function. So what happens if we call this like before? We say, okay, well, we called the function, we get back a value. Let's just print the value. Function anonymous. Okay, so we got back this. It's an anonymous function. There's no name on it. Now we get back foo because it's no longer anonymous. Okay. So the problem is not whether or not it has a name. Oh, it's a function, right? So you'd have to call the function. Let's call the function. Now we get back a 1 and a 1 and a 1. It never changes. Okay, so why isn't it changing? We're doing I plus 1. Oh, but I plus 1, that doesn't change I, right? So we could do I equals I plus 1. We can do I plus plus. There's a couple of different ways of doing it. Honestly, I prefer this one. I just find that the assignment, because the equal sign is there, I like consistency. Plus plus as a prefix or as a postfix to increment a value, I don't like it. I always have to stop and think, okay, do I get the value before it's incremented, or do I get the value after it's incremented? And that just drives me crazy. I don't like crazy things. Okay, so this still doesn't work. Why doesn't it work? The reason that it doesn't work is because of the way that it's written. What we want is we want to change I equals I plus 1, and then we want to return the I. Okay, so what happens if we called this, well, technically we could probably still do it exactly here. What happens if we call this a bunch of times in a row? Look at that. It does count up. How cool is that? So why does it count up? What is going on here? What is this scary looking code? First off, just to make it more readable, I would do probably something like this. I just think it's probably more readable that way. Still works. You want to make sure that your code still works. So run it early and run it often. Okay, so let's just talk about this for a second. We have a function. We have created a variable inside of here. It's a value, so that should be on the stack. Okay, then we return a function. That's going to be on the heap. We modify something that's on the stack. And then we return that thing from the stack, right? Kind of, but not really, because all of this is wrapped inside of a function. We now have created a closure. We have closed over this value. As soon as we return this function and a reference is pointed back, because this is on the heap, this is now on the heap, this is now on the heap, this is now on the heap. And that's why it can stick around. That's why we don't lose the state. If it was really on the stack like we had before in the previous impure example, you can see that it doesn't actually change the variable permanently because it's on the stack. As soon as it gets put onto the heap through a closure, as long as we have a reference to this thing right here, these variables will not be cleaned up because they're on the heap. They're part of the object, and the object will maintain its own state. How are we doing for time? We're about 10 minutes from the end of vanilla JavaScript for beginners. This shit is really, really, really important. I think this is the most important stuff that you can learn if you're just learning JavaScript. Is this too advanced for people who are just starting? I don't think so. It might be too advanced for somebody who's never written a line of code in their life. But then again, everything they write is going to be too advanced for them if they've never written a line of code in their life, right? Now, I want you to notice that I haven't harped a lot on variables, on assignment. In fact, the only time we really needed assignment so far has been this closure example. Before that, we didn't even have assignment. This is because if you think imperatively, you're going to think in terms of variables. If you think functionally, you're going to think in terms of functions. And thinking in functions is always superior to thinking in variables, because thinking functionally is not always better than imperative. If you have to twiddle state for like optimization games to like make your code run as fast as possible, which you can't do in JavaScript anyway, there's no state twiddling. If you have to like bounce down some lower level to do something, like use a for loop instead of a reduce, because you're dealing with lots and lots and lots of data, like, you know, hundreds of thousands or millions of records in an array, it's probably a time where you're going to have to switch your brain to imperative coding. But if you're learning JavaScript and you're going to be a web developer, you're going to be a JavaScripter that works like web, serverless, full stack, but you're not writing like services written in JavaScript that support 1 million users, which you shouldn't do anyway. You really should be thinking functionally, not imperatively. It'll solve so many of your problems with JavaScript. People think that JavaScript is this scary, dangerous, mean, horrible, ugly language. It's kind of, but it's mostly the people that are implementing it and using it and teaching it that make all of the, the discombobulation. So this course will continue tomorrow. We're going to continue probably for the next 3 weeks, I would say, where I'm going to show you new things about JavaScript every single day. It's going to get progressively more, not difficult, but progressively more complex as we build up things and we learn to look at more complicated JavaScript code. I guess that basically gives us time for some questions. Let's see if anybody has any. I want to welcome back Chris, Magic Eagle, Northern Chimp, Dante, Josh, Sudeep. Wow. Awesome, guys. And we've got Gurv over on Twitch. All right, I'll say hi to YouTube first because there's more people on YouTube, and then I'll say hi to Twitch, and I'll answer any questions you guys have. Open close. No, this will not be open close principle. Sudeep, primitive, backpacking variables to functions. I'm not sure what backpacking is. I've never heard that term. I guess backpacking is closure. Is that what you're calling it? How does closure differ from recursion? Recursion will keep going. Closure doesn't keep going. Closure is like it calls once, it stops. It calls once, it stops. Recursion calls itself, so it'll go over and over and over. And you don't want to do recursion in JavaScript. JavaScript is not tail optimized, which means that when you're putting these function calls on the stack, you eventually run out of stack. And when you run out of stack, your calls are not going to work. What helps me with it is a thought framework that focuses on the outputs of the functions and reverses engineering from there. All right, so what's up, Gurvy J? I'll just call you J. Is that cool? Can I call you J Grill? I think J Grill is a great name, by the way. He says you can also assign x equals x plus x, which is what I ended up doing. It looks like he's got a spread operator in there. Wow, I think somebody else might have a little bit of Lisp in their past. Well, spread operators aren't from Lisp, but the whole idea of car and CDR definitely is. Which, by the way, is how functional languages generally handle recursion. It's generally not a function that calls a function or procedure that calls the same procedure. Generally, it's handled through a list. So if you could think of JavaScript interview questions, if you want to take the break to look up some tricky JavaScript interview questions, if you've been given JavaScript interview questions and it stumped you, or you thought you fumbled through it, or you just weren't sure how to solve it, now's your chance. Make sure you join the Discord. The link is in the description. When you join the Discord, is the Discord link in the description? Okay, good. Yeah, join the link to the Discord in there, and then you can post the links to the code examples, to the JavaScript gotchas that you would like me to tackle. The JavaScript interview questions is really around building you up so that you can interview and sound competent when you speak about JavaScript. Thank you so much for hanging out with me this morning. This has been Vanilla JavaScript for Beginners, and I have been Mark, and I will see you in a couple of minutes. Happy Turkey Day.